Good morning. Welcome to today's webinar. Today we're going to be covering the information that's the exercises in chapters 3 and 4 of the FDOT SS3 Design and 3D Modeling course guide. It's available online on our training link for the ECSO website. We've got a lot to cover, so I want to get into what we're going to, basically a menu of what we're going to cover today. I'm going to try to spend the first part of the hour on developing 2D plans, and that would be the planimetrics, not necessarily the plan and profile sheets, but the actual design geometrics. Using the new tools in GeoPack SS3 or Power GeoPack SS3. I'll cover basically if you want to set the new civil features on MicroStation elements on things that are already drawn out there. And then we'll go into the horizontal geometry tools, learn a little bit about how to use Civil AccuDraw versus MicroStation AccuDraw. And then for the most part of it, we're going to sort of build our roadway with civil cells, and you'll see various civil cells that automate the process for developing the planimetrics on a project. The second part of the session, we're going to cover the profiles or vertical geometry in SS3. We'll be creating an existing ground profile on our centerline, and then using the vertical geometry tools, some with Civil AccuDraw, some without, to develop a design profile. Once we have that design profile, we'll go ahead and I'll show you how you can edit it. You can basically create using different tools to create the profiles or the vertical geometry for your centerline. And then I'll show you how to report on that and export it to a GPK file or a land XML file. Okay. So let me just get into a FDOT SS3 session. This is of course, our workspace, version 1.0, the FDOT SS3. I always like to show that so people know which workspace we're working in here. And this is the results of what you would have out of Chapter 2 of the Design and 3D Modeling Manual, where essentially what we've done is created our design centerline for our proposed road. This project is basically being realigned from this skewed type intersection to an intersection that's more at 90 degrees. Thus the proposed centerline here. Now, one of the things that we're going to do on this project is to mill this existing State Road 98. So in order to do that, I'm going to leverage the topo file to get my milling limits. And I'm going to use a new utility called reference file copy levels. So what I'm going to do is, this is a new tool. It's sort of like the merge to master, but I don't have to worry about turning off levels in the topo file. So you can see I've got this topo file in the background, and now I've opened up this copy reference file levels under it's a new utility under Design Apps, reference file, copy reference file levels. I'm going to scroll down. All of the reference files that I have attached are in this left list here. So you see I've got the topo file, and not only is it by the reference file, but it also tells me the model of the reference file that I have attached. As you notice down here, I actually have two alignment files that show the stationing in different scales. So I've got a 50 scale model and a 40 scale model. So that just shows that you can do it by model. That's a new improvement to the tool. Now what I want to do is find the existing pavement asphalt lines. I'm going to add them to this list on the right here, and when I process, it's going to copy those lines into this active file, and then I'm going to turn off the reference file. So as soon as I process, you can see that the reference file now has been the levels have been turned off in this reference file, but it is still attached. So I'm going to go ahead and undisplay the topo file. And then I'm going to Essentially, I don't need a lot of these lines, so I can delete these lines, and I would recommend in the course guide that you go ahead and do that. You can just either place a fence or just highlight them that way and delete them, because the project limits only go to where that center line kind of comes back in there. So I'm just deleting a few of these lines for now. And then what I want to do is make these milling limit features with the new set feature tool in FDOT SS3. But before I do that, I probably need to, since this road is being realigned, I probably need to just draw a line across here and then break these elements. So I'm just showing some basic tools here. Instead of using MicroStation to draw this line, I'm going to use the new civil geometry place line between points. And when I do that, it brings up this dialog where I can set the feature, and I'll just pick the milling limits as a feature to draw. And then as I hover over vertices, it will show me a key point snap. So I'm going to essentially snap to these points like that. And then I'll use the MicroStation break element tool. It's a MicroStation tool, obviously. And I'm going to zoom in here until I get to that point, and I'll break it at that location. And then I'll basically break it at this location. And now I have two separate elements here. The reason I did that is because I don't necessarily care to mill this part of this roadway, because it's going to be essentially abandoned and the new alignment will be there. And then what I'll do is I'll just strike a selection window here, and I get all of the elements. And if there's any elements in that I don't want, like that, possibly this baseline here, then I can just subtract it. And what I'm going to do here is just use the set feature tool. And when I set the feature, I'm going to go ahead and pick the milling limits on this one as well, pavement milling, and it will use a default name of ML. And then if I data point, you notice that it's already it has the counter of the selection items in that cursor. As soon as I data point, now I've essentially made these milling limits intelligent civil geometry milling elements in this file. If I hover over it, you'll see that they each now have a number. It just incremented the number for each of these, and they're now in this file. And so I can use those for targeting in my template. Now the next thing I want to do is use some of these tools with partial offsets. So I can go to the horizontal geometry tool and do a single offset partial, and it'll bring up this dialog. And now this is kind of like a copy parallel, only it allows you to do, distances, as you'll see, and you can put in station values and such. But what I'm going to do is first pick the element that I want to copy, and then I can either use the direction, or I'm sorry, distance or length. And what I'm going to do is set the I'm just going to eyeball this in here for the time being, and just to show you that I'm really just copying a line at an offset from here to, and I can snap on points if I want to. I've got points here that I can snap to. So if I click that like that and then choose no, not to mirror it, which is another data point, then if I go select this item, it shows me how that element was placed. And in this case, I can change it from a 48 foot offset to just say 16 feet or 24 feet, however. And then I can also change the begin station to a specific number, 2800, and it moves the line back. If I want to change this length, I could change the length to 500 feet, so it's an even length. Or I could go in and change the, the end station. The point being is it's more than just copy parallel, because it has intelligence to it as a civil element. All right, then I'm going to do the same thing. I can just, again, I'll just use the partial offset tool, single offset partial, and again I'll snap to, first I'll locate the baseline, and I am also placing edge of pavement lines out here. That was something that was previously set in that dialog. So I'm going to click, I'll just click on a point right here and then edit it later. And then I'll just extend it out to basically this point right here. What I'm doing is I'm creating the widening lines for this. And then this I've found to be the easiest way is just draw a line out there and then set it however you like. So 32 feet will be my offset. And then I can change this end station, or I can change the length to an even 600 feet and have it like that. I'm going to draw another one on this side over here, which is I'm just going to basically go from the start of this line here, and I'll extend it all the way to this point here. And you'll notice that this line got put on the wrong side. Not to worry, all you've got to do is select it and change that distance from, and actually I selected that. I don't think I selected the right one. So that's the one I want. Actually, I did. And I'll set it to -24. And now it's on the opposite side. And so that's how easy it is to place parallel lines, and you can modify them once you have them out there. Looks like I hit 25, -24. And so that's basically placing partial lines, and that's how you can do parallel offsets. But we also have, like for example on this tool, I want to put in 4-lane divided planimetrics. So and I want to do it within limits. Now I could use that same partial offset tool and do it however many times for the parallel lines, or I could just essentially set the limits for the lines and then do it once with a civil cell. So what I'm going to do next is do the same thing, single offset partial, and I'm going to change this to a construction line green. I'll just do construction line green so it's easier to see. And instead of selecting this baseline, I'm going to select this SR 61 baseline. And then I'm going to snap to a location where my milling limits and this baseline start. So that'll be the start location. And then it's going to track me, and I want to go over to the other side of this intersection, and I'm just going to find a point right here, and I'll essentially just copy that line there. Now you don't see it, but if I were to turn off this construction limits line, you would see there's the green line that I just placed. Okay, and I placed that so that essentially it was a 0-foot offset. If I'm a 0 offset, so it's right underneath that line, and then I can use a civil cell that has all the parallel line work for that. So let me turn that level off again so you can see how it works. Now I'm going to go select the Place Civil Cell tool, and that's under this Civil Cell section. And it'll bring up the dialog list option here, and I'll pick on the 3 dots, and that opens up like a browse utility. And here are all the civil cells that we've delivered with FDOT SS3, this first release. And if you'll notice, there's a bunch of, if you will, PPM template type civil cells out here, basically from this 2-lane, 2-way, all the way down to the 4-lane divided. Actually, ramp B and ramp C and shared use path are also. If you click on them, you'll have to open them, but it basically shows the line work, the 2D line work that's associated with each of these templates. So I'm going to pick this one here, the 45 miles per hour or less, and it'll show me all the line work. And then when I choose OK, the prompt will ask me for the reference element or the center line that I want to place these parallel to. So I'm going to click that line, and automatically it goes out there and it does the parallel line work for me. So now you see I've got the curb, the median here, the 22-foot median with a type E curb. And if you hover over these, they actually have the correct feature for quantities. So if you were to run the quantity manager against this, you would get the correct lengths for each of these lines because they're all featurized and attached to a DDB feature or a DDB element. Okay, so once I have that, then I can use some other civil cells. Like for example, in here, I want to place a right turn lane into this roadway. Okay, so we have other civil cells out here, and if I pick again here and go to intersections, you see there's a right turn lane, and this dialog will in red show you the reference elements that it wants you to pick. And as we build these, we try to make them intelligent so that when the prompts come up, it should make sense what element you're supposed to pick to place them. And so there is two edge of pavements, it looks like here. So when I choose OK, it's going to ask me for the edge of pavement on one side. And if you get it wrong, you can always reset and go back. And then the edge of pavement on the other side. And then you'll see that when I place the other side that you'll need to do a reset. But for this, in this case, it solved it. But if you did have to change this, if you hover over the two reference elements, you'll see this direction arrow, and that's what allows you to flip it into the orientation that you need. It isn't going to make sense to you until you see it the wrong way, which we will in a second. So I'm just going to reset for alternates and accept the civil cell. And now I've essentially placed the geometrics for the right turn lane out there. And of course, there's some other things that need to be put in here, but for the time being, this is what we've got. And if you want to change this length to, let's say, 500 feet, it's going to change the storage length all the way back there. And if you want to change, you know, this offset or change the taper rate, let's see, this taper rate is actually set for two 12-foot lanes, but if you wanted to change this to 50 feet, it will automatically just trim that up. And anytime you do any of these civil placements or civil cell placements or anything with drawing lines, all of the MicroStation Control Z's work. So notice that I just changed that back to the 135 feet, and if I wanted to use Control R or redo, it will place it back to that. So that's how easy it is going to be to put in a you know, a 2D turn lane. Now if you wanted to change this radius, it's just a matter of picking the element, changing it to 60 feet or something like that. And if you watch, this storage length goes from the end of the radius point, so you have that built into the civil cell. So if I do Control Z again, you'll see that it changed the radius back to what, 25 feet, and it also changed this, it moved this back up the line. So it's all rule-based and civil intent-based. I just call it rule-based. The way it was built, it's built on rules so that this taper comes off of the end of this line, this storage length comes off the end of this radius. So if you change one, they're all going to ripple down the way they were built. So that's a right turn. Let's look at a left turn. So we've got a situation where we want to put in a left turn lane in this median at this intersection. So we have civil cells out here as well, and we have one that's in this case we're going to put a traffic separator in the median. So here's the left turn with traffic separator, and you see that it will work on a curve, and this is essentially the geometry that's going to build in there. It's going to put in a turning radius that is going to control the location of the end of that traffic separator, at least to the nose point, and then it will put in the storage length and then taper back to whatever the standard median width is there. And then you use MicroStation modifies to basically clean up the intersection, which is what we'll do. And notice there's two reference lines here as well. There's a center line of the road you're turning on, and then there's an edge of pavement reference, which would be the right edge of pavement in the direction of travel. So I'm going to select the center line. I'm going to select the right edge of pavement in the direction of travel, and it's going to try to solve this, and notice that it doesn't look anything like a traffic separator, and that's because the references need to be flipped in this case. So when I flip it like that, it still doesn't look right. So when I flip this side, now you'll see that this turning radius comes in here, and it's got also the taper is trying to flash there for you. And so I'm going to reset for alternates and accept the civil cell. And now I've got, if you look, I've got the taper with a traffic separator, and there's actually a little green line out here that is setting the storage length. And then it's just a matter of using MicroStation. In this case, we're going to use the MicroStation Trim to Intersection tool. And I'll just select this line and this line, and select this line, and yep, let me Control Z. I think I had one extra click in there, so I'm going to run that tool again and select those two. And the reason I'm doing it this way is because I wouldn't want to trim to a particular line, because these are actually at a skewed angle, the angle that's 90 to the way this is. And then for this, we actually create a little construction line for you to trim to. So you can do a trim to element and then select the element, and you can use a control key and then select the cutting element, and they all get trimmed back, and there's what your left turn lane would look like. And like I said, these are construction lines that we're using. If you hit your F7 key, it will turn off all the construction class elements, and it cleans up your intersection real nice. F7 will turn them back on. So if you want to modify something, let's say the storage length, instead of being 200 feet, for your project it's supposed to be 335. So you just change the dimension of it, and it basically trims out everything. And because of the way that it was built with the trims and everything else, that left turn lane gets placed in there real nice. Same thing if you wanted to change this turning radius from 100 feet to maybe 65 feet, it's going to pull it down so that you're also adjusting it that way. The other thing is that this was built with offsets, so if you're not turning right to the center line and you're actually going to be maybe 6 feet off of it, you can change that dimension as well, and now it moves that as well. We are going to be developing other civil cells for these turning movements, such that if you're turning from another roadway this way, you're not going to interfere with the traffic separator that way. So it'd be a left turn from the opposite road, because right now if you were to try to put in maybe a larger radius, you might clip the end of this traffic separator here. So we'll be developing these as we go. Then I'll just go ahead and put in here a circle, or just a normal radius in here, and for this quadrant we're going to set in 110 feet, and this will ask for 2 edge of pavements, or 2 lines, just like a normal fillet would. And then you select, notice that the radius is locked. If I didn't have it locked, I could sort of eyeball it, but I don't know anybody that does that. You can also, just as you're moving the cursor, you can lock it by just keying the number in and hitting enter. Notice the lock key comes up, and it also sets this checked locked radius there. So when you data point, then it's going to ask you if you want to trim the elements, and I'll go ahead and trim both. And now you'll see that I've got this right turn here onto the roadway, and now I have this. But notice that I also have some line work here to clean up. So what you can do is, the way these were built is everything is built from the center line to the edge of pavement on the median, and then it'll be a lane width, and then from the outside edge of pavement outward, just like you would dimension it. So because I trimmed the edge of pavement line, it's automatically back there. Now it's still there. If you were to try to select on it, there's actually an edge of pavement line out here, but just because it's trimmed back. So that one got trimmed back, but it doesn't trim back all the references or the lines that were made from it. So all you have to do is click the very first one, and this would be the face of curb, which is usually 1.5 feet from the edge of pavement. If you select this one, now there's a little issue with dragging. There are these handles here that you can grab, and unfortunately when it's really close to another line, you can't really grab it. So you can change the station first. Like, I'm just going to set this to 50, which basically moves it up the alignment 50 feet, because it's basically off of this line. And then once I have it up there, then I can grab this. I don't know if you see, there's 2 arrows and a ball. I want to click this arrow in the front, and it will start. No, let me zoom in a little closer. I'm going to select this arrow right here, And when I do that, I'm dragging this, and I want to drag it back to the location of the radius point, which is right here. And by doing that, because all of these are built from this line, they all trim together. And then I'll do the same thing here. This element right here, if you look at it, it has trim extend to none. And so if I want to trim this edge of pavement line, because of the way this was built, the trim extend was set to none. So if I change this to both, then it will trim back that line. Well, it should have trimmed back that line, but looks like it doesn't want to. If it doesn't, you can just grab it and select the handle this way and go back to the radius point on this side, or not. Change the station here to 50, and change this one to 50. Okay, so then if I grab it, I should be able to grab this handle, and they should all go with it. And then that's the trimming there. Okay, it doesn't go all the way around, unfortunately. When you place in a fillet, it won't fillet all of the lines that are essentially designed off of it. But that's okay, because we have a civil cell that'll do that simple parallel line work. So if you go to place civil cell, again, we'll go to the intersections, and we have curb sidewalk lines out here, which basically draws the curb and the sidewalk lines, just like it says. And you just choose OK, select the line. And then if it comes in on the wrong side, it's because of the way it was built. You just click the arrow, and it flips it over to the right location. And then you can reset and accept. Do the same thing on this side. And accept. And I guess I pulled that one back too far. So, all right, but that's just my clumsy line work. But now you'll notice that these aren't necessarily matching, because one was built with a 3-foot utility strip and a 5-foot sidewalk. The other one was built with a 2-foot utility strip and a 5-foot sidewalk. But that's easy to fix. We can just select the one and change it from -2 to -3, and because of the way they were built, now everything matches up. So that's basically simple sort of line work, and creating civil cells is just as simple as that. Let's say I wanted to modify this. Well, I did modify it, and now I want to create a civil cell from the modifications, or I want to basically place this same changed civil cell to another location. I could, so if I wanted, basically I could delete this civil cell and then place it over here from the one that I just modified. And let me look at the time. I don't know if I have time to really demonstrate that, but those are some of the tools for doing that. Now I could continue on and place parallel offsets of this line, and then put in fillets on this side, and put a right turn lane, and continue building this 2D line work. We have some other civil cells out there that will assist in some of this work. We have curb transitions out here for putting in the flared ends, whether it's on the back side of a line or the front side of a line, straight. We have all the different types of flares that you would have out there. We've also started building driveways. So there's a rural turnout here. There's an urban driveway that works off of a line. So let's say, for example, I needed to put a driveway in here. Let me just draw a construction line out here. And this would be 2D. So where'd my construction lines go? Let me do a blue line. I'll just go from here to here. And then let's say I want to put a driveway civil cell. I can just go to the place civil cells, select driveways, urban, and this is a 2D urban. Notice there's 2D versions and 3D versions. And it's going to ask me for the reference element, and then the wrong one. Let me try that again. So intersections, whoops, driveways. So it wants to know where my back of sidewalk line is, and then where my blue dash line is, and then where the front of sidewalk is. And it basically tries to place it with the orientation that it was. So if I flip this line and flip this line, whoops, flip this line, and flip this line, it should place it in there in the right orientation. You see, it's I think I should have picked the edge of pavement first and then the back of sidewalk, I think is what I did. So let me just escape out of this. I won't accept this. At any rate, we have the driveways that you can place out there, also sidewalk ramps. So let's say, again, say I had a line right here, and I want to place a ramp, a 2D ramp, so I can go over to these curb ramps and find the ramp that I'm looking for. That would be one like this. And then it'll ask for the blue line and then the edge of pavement, and then whatever optional references like the curb lines and the back of sidewalk lines. And it will essentially draw in the curb ramp there for you and the pad in this case. So this would be the little truncated dome pad, and then there's your ramp configured at that orientation. And if all works correctly, if you were to change something, like let's say this had to change to a 100-foot radius, then everything is basically redrawn and reconfigured according to the way it was designed in the civil cells for everything. So we've tried to make some of the civil cells to automate a lot of your planimetric work, and we're recommending that you try to use all of the new civil tools for placing your planimetrics in as opposed to using MicroStation elements, with the exception of things that, like in this case, it's obvious I don't want to trace over anything that I've already done. I can always refeaturize them with the place or set feature tool in the civil geometry tools as well. Okay, so that covers a little bit of the horizontal geometry. I didn't get to complete this whole project, but you know, I got a lot of it done. Now let's look at the profiling tools. And the profiling tools are under the vertical geometry, but before I can essentially profile anything, I need to have attached or have a reference terrain to work from. So I'm going to go over to my reference files, and let's see, I need to attach from the survey folder a terrain that was imported back in the chapter 1 of this course guide. And you see the boundary of the terrain comes in here. If I click on it, in order to see a profile on a line, you need to make sure that you have whatever reference terrain or whatever terrain you have in your file. In this case, it's always going to be a reference terrain. You need to set it as active. So for example, if I were to ask to open a profile model on this center line and then select a view to place it in, I'm not going to get anything. That's a common error that we're starting to hear from, and that is because I didn't set active any terrain for that matter. So if I click on this line and then choose set active, notice how the profile automatically appeared. That is essentially your existing ground profile of your center line. Okay, so there's no need, even if you're importing your baselines from your GPK file, there's no need. Actually, we recommend you don't import your existing ground profile from the GPK, just because it's so easy to just attach the terrain and then go to your existing ground. Okay, once you have that, then there's lots of vertical geometry tools that you can do to create your profile. So this is what the existing ground looks like. Here's the crossroad that we're actually tying to. If you look at this line, actually kind of crosses the existing US 98 here, and then you have it, notice it goes up a hill pretty, actually not drastically, it's a couple of feet in whatever, I guess about 50 feet or something like that. So then you can click on this. They won't show you the essentially the PIs or for an existing ground, you won't see the PIs and the slopes, but anything that you trace onto it, you would. The other thing about this profile is it's if you use your shift and control key, you can change the vertical exaggeration and the horizontal exaggeration. So whatever you like. I think you can also set it in here specifically. Like if you wanted to use a 10 exaggeration that you were working in, then you're always working in 10 exaggeration this way. And that's in the view attributes. There's other things about this profile view. This is a view settings in SS3 such that there's some other tools here, like for example fit profile extents or fit plan extents. So notice that I'm only looking at a portion of this baseline. So when I do the fit plan extents, it only fits the profile in that portion. But if I were to zoom out and then choose fit plan extents, I'm going to see the whole profile. Or I can just hit this other one, which is fit the profile extents. All right. Now, most of the tools for building vertical profiles are on this R row right here, but there's some others here for placing parallels to elements between two lines. You can, there's a lot of these other which are we're going to cover more in the advanced detail modeling chapter 9 later on in one of the other webinars, but for today I'm just going to kind of focus on most of these tools right here. And the first one I'm going to use, you can also access most of these from this last icon. If you just hold down this little arrow, almost everything that's in this list is on this list. Not everything, but a lot of it. The one that we first start with in this exercise is define profile by best fit. And what it will do is it will bring up this dialog, and it has several things that you can enter in it. The first thing it wants to know is you're going to make this complex, and I don't know what the other options are, or make them a single element. I'm going to make it a complex element, and then I'm going to essentially follow the prompts, click the profile, the existing ground profile, and now it's going to try to build a profile based on the constraints that I've given it in this parameters section. So I'm looking at an upper envelope on the existing ground of 2 feet, a lower envelope below it minus 2.5 feet. Because of the design speed, I've set my desirable crest and sag curve length values as well as my minimum curve length values. And then I'm also giving it a profile name. And in this case, I'm going to set this to element template to none. And then after it's been set in the parameter section of the dialog, the way this tool works and most of the tools work is you're going to get to verify it with data points. So essentially it cycles through each of those options. It shows that you have them locked, and then you can override them or go ahead and accept them. And what you end up with is this profile that fits within those parameters. And you notice that it's not going to hit the existing baseline, so we're going to have to modify that. And it's also not going to tie to ground when it gets back to here, so we got to modify that. But it gives us a good start. And the other thing that we like to do is check it versus the design standards. So in general geometry, if you go to the design standards toolbar, you can pick a particular facility that you're designing. In this case, it's a rural facility. I'm going to choose 55 miles per hour. And then I'm going to use this tool that basically is to check it or set the design standard on an alignment. So I'm going to set this on this alignment, and then notice that I've got these extra little icons that show up on my profile. So I've got the red X and I've got this yellow sort of warning symbol. And these are either, well, they're just notes to the designer that you have some things to check based on the plans preparation manual for this type of facility. And so if I go to the Civil Message Center, I'm going to see all of those warnings and all the errors. So unfortunately, though, this is in stations. Like it says the sag length is less than minimum, where the standard value is 2.5 stations and the actual value is 2 stations, which would be 250 feet or 200 feet. And then I have some warnings that says the slope is less than minimum. For a curved facility, it needs to be 0.3 and the actual value is 0.24. So these are warnings, these are errors. And so you can see them. If you wanted to, like if you had several of them and you wanted to sort of zoom into one of them, you can just click on any one of these and then do a right click and then zoom to, and it zooms to the error in the plan view. Oh, that must have been a plan view error. So let me zoom to one of these. And it should have zoomed to, or centered at least, the error on that one. So all I'd have to do in this case, I'm just going to change this to a 45-mile-an-hour speed and reset it. And most of those errors should go away because that's how I set the best fits. The only thing is this one here, and this is probably a slope one, I would imagine. You can hover over it too if you get to the right one, and it usually tells you, there it goes, slope value. I'm just going to disregard that one for now. I'm going to show you how to do some profile edits to the best fit profile. Now this thing comes in, and if you click on it, you can see that all of the dimensions are shown, or all the parameters for this profile are shown, but you can't edit them. You can't edit them because of the rule that it was built on, which was best fit. If you want to take that rule off, then you can just click on this element and convert it to a general profile rule. And when you do that, now if you click on it, you can actually change some of these values. You can also do other things like, for example, I want to delete these first two PIs. So I'm going to use the MicroStation Delete Vertex tool. I'm going to click on this first point, and that goes away, and I'll click on the second point, and that goes away. But it kept the rest of my best fit profile. And then, of course, the Control Z would work here, or Control R. So even if you made a change and you thought, well, I really didn't want to go that far with it, then you can just use your Control Z, and it essentially is right there. And then what I'm going to do is I'm going to try to tie to this existing ground. So what I can do is just use a profile line between points. And if I wanted to chain these elements together, so for example, if I just click here and then click here, notice that it's not going to continue on. And I would have to go pick this point here and pick this point here, and now I basically traced it. Or I can Control Z and undo those two. And if I want to chain those together, what I need to do is bring up this Design Standards toolbar here. Not that one. The Feature Toggles toolbar. And there's a little chain option here. And I don't know if there's another place for it or not. Actually, there is right here. So you can chain them this way as well. And what you're essentially doing is, if you click this box, then as you draw things, whether you're drawing horizontal or vertical, it will remember the last point that you drew. So let me just trace a few points here, and you'll see what I'm talking about. See how it's rubber banding now? So it's like a line string instead of a just place line tool. And so that's one way of just draping or trying to match the existing. Now I can do also a vertical line more specific. I can set like a specific slope and length. So I could do that with Civil AccuDraw. So I'm going to toggle off this and turn this off. I'm also going to turn off the Design Standards toolbar. And I'm going to go in and open up the Civil AccuDraw. And notice that my MicroStation AccuDraw turned off. And notice that it's also now, if you're used to seeing this in the horizontal mode, it's now set to a profiling Civil AccuDraw. And again, if I were to like dock this down here and then use the F8 key, notice how the MicroStation AccuDraw comes up and the Civil AccuDraw turns off. That's another enhancement that we added to the workspace. So that you can just toggle it on and off. The main reason for that is that there are several key-ins that are the same between MicroStation AccuDraw and Civil AccuDraw, so we recommend that you only have one on at a time. I'll just pull it up here because I like to see the kind of keep it aware. And what it's doing is it's giving me a heads up of where I'm located in the. Now, if I wanted to set this to elevation, it would tell me what my elevation is in my profile here. So it's tracking me in the profile window. And then if I set it to slope, what I'm going to do is I'm going to start on this endpoint, and then I can lock the slope by just tabbing to the slope field and keying in -2. And then if I want to set the length, I can tab to the length field and choose 16 feet. And now I've placed a specific line out there that is 16 feet at 2%. Or I could have just used that just like I did before in the vertical tools. Let's say I wanted to draw a line out here that was a specific, and I'm just going to eyeball it for now. Whenever you place something, it has the information. So if I wanted to set this at 0%, I could just change it this way. And if I wanted this to be 15 feet or 10 feet, I could change it that way. And now I've basically done the same thing two different ways. One with Civil AccuDraw and one with just using the dimensions or the intelligence of the element itself. And once I've got that sort of placed in here, then I'm going to just join these together so that I can complex everything there. But over here, what I want to do is I want to use, well, a lot of people are used to using the VPI generator tool in the old Geopacks. Well, that same utility exists here. It's called Profile Complex by VPI. And then what you can do is either put in a curve parameter, your K value, or you can put in a curve length. I'm going to go ahead and use a 50-foot curve length, and I want to make sure it's set to a parabola. And right now I'm not really, I'm really not paying attention to any names, but if you were ever to export it to a GPK, you have to make sure that all these have a name that is a you know, Geopack compliant name, and that's Geopack compliant for Kogo. So you would want to make sure that it fits within those parameters. But for this case, I'm just going to place in a another profile that basically puts a curve between PIs. So what I'm doing is I'm just snapping to points on my existing ground, and as I notice as I move, it's placing in that. So this is like the vertical VPI generator tool. And don't judge me on my vertical profile here, but when I reset, and now I've got essentially that type of a profile there. And I've basically tied into this existing 10-foot slope here. You could put curves between tangents if you want, but what I'm going to do next is just complex this all together. The easiest way to do this is to turn off the level of this green line, which I know is on my excess ground line here. I'm just going to turn that off in my profile. And then I'm going to use another tool over here called Complex by Elements. And whenever you use Complex by Elements, you want to make sure that you get to the beginning of the first element. You can either do it, it's kind of just like the complex chain. You can either do automatic or you can do manual. I'm going to give it a name here, and then I'm not going to worry about an element template. But the one thing you want to do is make sure that the arrow, notice if I get on one side of the line or the other, the arrow will be in the wrong direction. Looks like it not so much in this case, but I'm just going to go ahead and click on this. And since it's automatic, it should have gone all the way to the end, and so I'm going to accept it. But the way I can verify is if I just click on that whole thing, now you see I've got a complex profile out here, and it tells me what the profile name is. And if I needed to change any of these dimensions, I could go in and change them accordingly. But there is my design profile. And then in order to see it, in order to see the 3D representation of this line, all I'd have to do is click on the line and choose Set as Active Profile. And then if I use my F2 key, it will open up the isometric view, and it will fit the plan view. Let me delete these elements, I don't want those. And it will fit the plan view as well. So there you can see my center line of my profile, and if I rotate around here and kind of zoom in, you'll see that it does have vertical, you know, there's the ditch, and there's that's where it kind of crosses the existing State Road 98, and continues on going up and down. And if you rotate it, you can see that it's a 3D line, and that's how easy it is to build your existing profile. Now, as far as reporting and exporting, I'm going to open up that profile again. In order to report on anything, all you have to do is just click on it, and you'll get the paperclip icon. That's one way of doing it. Or you can always get the reporting tools from the actual section task and find the paperclip icon. So once I have that, then I'll just go ahead and choose Profile Report, and there's the vertical alignment report that's associated with this. And there are several other types of vertical reports out here that you can create. One of them actually is export to land XML, and so there you see it's going to have the horizontal geometry at the top, and then it will have the vertical geometry down here at the bottom. So there's the profile alignment, there's the actual name of it. So it's just as simple as clicking on a different report style. Once you have that report style, then you can save it off as any type of file, well, not any type of file, but a text file, a land XML file in this case, and you can place it in your current project or somewhere on your computer, whatever. And then you have that saved as an XML that you can give to the contractor. So that's how simple it is in SS3 to do profiling. So that was reporting. Now let's talk about exporting. So if you wanted to put this in a GPK file, because when you go to do plan development, as you notice right now, we can't, well, not we can't, but I'm not creating plan and profile sheets, and I'm not clipping this profile to meet plan and profile sheets for a 50 scale project, because right now all I'm doing is designing. When you get ready to create your plan and profile sheets from your planometrics and your profiles, what you would do is go utilize the legacy tools for the plan and profile clipping. And in order to do that, it needs to be, you need to have a chain and a profile. So in order to get that into the GPK, all you would do is come over to the general geometry, and there is this export to native tool. When you click on that, then you can locate the element. If I locate this element, it knows that it's a child, or it's basically married to the center line of this SR61. And because it is the active profile, it actually exports to the GPK along with the SR61. So all I've got to do is click on this element and reset, and then pick the GPK that I want to put it in, and I'll choose OK. And now it will tell me down here that it exported it. And of course, I always verify these things. It's just my nature. So I'm going to go to the road coordinate geometry tools, open up this GPK file, and then I'll go to the element profiles, and you'll see there's my new, obviously I had one stored out there before, but if I again, it says avoid names. It doesn't like that name with a dash in it, so I probably ought to rename it and re-export it. That'd be a good idea, because it's giving me a little warning here. So that's very easy to do. I'm just going to click back over here, cancel that, and I'm going to click on here. Actually, let me get out of Kogo. I don't know if it will actually update itself. I didn't want to do that. All right, so then I'm going to change the name of this. It's very simple to change the name. You just click on it and go to Properties, and then you can just change the name here. So I can take that dash out, and just for examples, I'm just going to call this Web. So State Road 61 profile in the webinar, and it's going to use that feature. And now I'm going to export it again and reset. Put it in this GPK, and it will it'll be placed out there. Go to element profiles, and there's the new one. If I describe it, I don't get that little warning anymore. And then also, of course, if you were to go to element chain utility, you're going to see the SR61, and you can describe that one as well. And they're independent now in the GPK file. So let's see, I've got about 6 minutes. Let me go look and see if there was any questions that I can help with. Hopefully, hopefully everyone was able to get their questions answered while I was doing the demonstration. So let me just open this up. and see if there was any that needed. Looks like most of them were. Okay. Does this method of creating profiles have the same accuracies as the old store by graphics? I would have to investigate that. I'm pretty sure that it's the new tools. They're going to be, the accuracy is based on your design file, and of course your design file now is you know um, is as accurate as you need it to be. It's not like the old MicroStation days where you had a limited design plane. As a matter of fact, if you go to the settings design file, this is where a lot of the civil geometry accuracy settings gets placed. So if something wasn't reading out to the right accuracy, you can change them here. This is also where you can change from K value to R value. Um, Here's where the precision is for your coordinates. If you want it to be 8 decimal places, you can change it. This is where you're setting, all the different display references. As you can see when you report on that, though, if I did a report on this and it gives me these values to 2 decimal places, I can go to Tools and then Format Options. I can change the report accuracy. This is different from the design file. Some people, when they've done these reports, it's come out in the metric like stationing. Notice how it changes it from 2 decimal or from 2 values after the plus sign to 3. That's because that's kind of a metric. If you change it to SS plus SS, it changes it to more of a what we think of as a conventional stationing format. But also all the precision accuracies are all out here. So the various values, and you can set it out to as many decimal places as you want. And now notice that the lengths and the slopes, well, in this case I would make the slopes, change that accuracy to 3 decimal places, and now I'm getting it to 3 decimal places there. So it's containing it all in what's called the civil element database. Speaking of database, Project Explorer, if you hit your F11 key or go to File, Project Explorer, we've made a lot of function key enhancements. So everything that's in this model now is can be looked at within the civil model tool of this design file. So all my linear elements out here, everything that I've placed in this design file, I can now get information on it. This is kind of like the database of information. So if I were to try to find that SR61 line right here, you'll see it's a complex element, but you'll also notice that underneath it, if I open that up, it has a profile that's associated with it. And here's the profile that I just renamed. There are some other profiles, the different little pieces that I built, but the actual complex profile here, this is the complex that was made by the best fit. But now this is the profile that I complexed at the end, and then you can see all the information is associated with it here. So all the things that it depends upon are all in here. And if you were to right click and go to properties, it will bring up a lot of the information on the element info dialog, and you can kind of look at all that information here as well. So all this stuff is being stored in the design file. It can all be accessed through the Project Explorer. You can get property information on it in element info. So it's just really it's getting a lot more powerful, and obviously it's being the GPK file is being kind of replaced, except where you need to use the GPK file for the legacy tools. And there you can see the export utility has been added so that anything that you do in the new tools can be exported to the old tools. And vice versa. If you want to still design some of your chains and your profiles with the old tools for the time being, I don't know why you would, but if you do, you can import those with the import utility. And that's what this does. And then you can just go out and pick in the roadway folder, there's a couple GPK files here. I want to select this one. Actually, I'll select this one. And it will bring up this tool. And let's say that I needed I've already got the profiles for a couple of the roads developed down here at Friendship. So let me just make sure I don't have anything else checked, and I'll import these. And then what I want to do is, in this case, I need to associate the profile that goes with, and it's probably an F. Well, actually, I don't think they had designed the Friendship profiles. So if I just import the chain without the profiles, then I could just go in and create the existing ground. So I'll just go ahead and choose import. And now you'll see that these two lines have been created out here. And then all I have to do is click on this line and go to the profile model, draw it here. And in order to see it draw, let me close this. In order to see it draw in this view, let me go back to a better ISO view, not perspective. In order to see these profile lines draw in the 3D, all I have to do is click on this line and choose Set Active. And now the existing 3D line gets drawn out there. And then it's just a matter of clicking this other line, which is the other side of Friendship, going to its profile, drawing it in this window, selecting the line and choosing Active. And now I've got essentially those existing ground profiles for the two side roads that are going to be part of this design. And that covers most of what I had planned to cover today. I hope you all learned something. If not, I'm sorry. If you didn't get everything, then of course this webinar has been recorded and will be posted within the next few days. So just go look out on our ECSO website under the posted webinars. Just kind of keep monitoring that, and you'll see this this session, Chapter 3 and 4, 2D plan and profiles with the FDOT SS3 Design and 3D Modeling course guide. So thank you for attending, and we can go ahead and stop this webinar.